Just before this session, I was actually out in the hallway chatting with some folks and found out that this was their very first reInvent. And it's so exciting to hear, and I love seeing people come here for the first time, just the grandeur of it, the excitement of it all. And it reminded me of the first time that I attended reInvent. It was actually back in 2014. And I was sitting in the keynote, and Andy Jassy took the stage, and he announced AWS Lambda. And that was quickly followed by Amazon ECS. So it was an incredible year of new releases. And it created a new dawn of application modernization. And for the next decade, I would spend working with customers, talking about cloud-native architecture and application modernization. My name is Ryan Peterson. I'm the worldwide tech leader for modernization here at AWS. So if the last decade of application modernization were concepts like serverless, containers, cloud-native, microservices, distributed architecture, we believe that the next 10 years is going to be about agentic AI. I'm going to walk through a bit of a primer of AI agents for the first half of this session. The second half is going to be spent doing a demo. So very much code walkthrough, actually seeing all of this in action. Wanted to start with just giving a little bit of a history of how we got here, because AI is a very broad topic, and you're going to hear about it a lot this week. And so wanted to just define kind of what makes 2025 the turning point to where agentic AI systems are going to see a launch within just about every organization that we're going to encounter. So we're all familiar with the idea of Gen AI, of conversational agents, of answering questions. But how did this come to be? It starts back in 2017 with transformers. And what this did is it enabled text to be processed in a fundamentally different way. Traditionally, using things like bag of words and n-grams, you would have to process text sequentially. And this had great limits into the scalability of how big we can build our models. Transformers changes by allowing parallel execution, allowing us a much greater amount of scale, able to process large corpus of text in a much more efficient way, and allowed us to build out models. This was followed by the discovery of scaling laws. So as these models were built and we increased compute, parameters, and data, we began to see predictable results. Increase in efficacy, increase in accuracy of these models as we scaled up these three aspects. What made this really fundamental in the change and the path to agentic AI is that it gave license to organizations to invest heavily in these to really increase models based on this predictable path of increased performance. Then we got into this few-shot reasoning-like type of behavior. And what's important here to realize is we're traveling along from just next token prediction into actual reasoning. And reasoning came about not because it was specifically programmed or designed into these models, but it was actually emergent based on the bigger models, the more parameters, the more data that was being trained on and compute capacity. Next, we got into the chain of thought. So if you remember early models, they were very bad at things like math. But if you can explain the reasoning of dissecting a word problem into its component parts and how it solved it, and give an example of that to the LLM, it got very good at it. And this wasn't additional training. This wasn't fine-tuning. This was actually just adding this as part of the prompt. Then came tool use. And this is where agents began the ability to actually interface with the outside world. This fundamentally changed the role of agents and how they can interact with disparate systems, get access to real-time data, and then actually act out in the real world. And that gave way to the React framework. So how can an agent reason, act, interpret, and then react? And finally, almost a year ago to the day, I think it was the end of November last year, Anthropic released the standardization model context protocol. And this gave way to really a large step advancement in agent development, because we now had a standard that we can all build towards. So going from left to right, we really increased the autonomy and business impact that AI agents could actually deliver. At AWS, we see billions of agents existing in the next few years, fundamentally changing how we build, deploy, and really interact with systems across the board. And the analysts agree and see that by 2028, 33% of enterprise software will include agentic AI. And that's up by just 1% that was observed last year. So we really are at the beginning of the hockey stick of agentic AI adoption. This next stat, I think, is even more telling, is that 15% of our day-to-day work decisions will be made autonomously through AI agents. So what are AI agents exactly? We throw the term around a lot. And so here's our definition. They're autonomous or semi-autonomous that can reason, plan, or act with both digital and physical. Physical becomes interesting. There's actually a colleague of mine that took a off-the-shelf LLM as well as off-the-shelf humanoid robotics, and were actually able to make it work and interact with its environment. That traditionally took very specialized models and training, but LLMs are actually able to reason and adapt and respond to these things in a physical environment and actually navigate and operate robotics even. We're going to go a little deeper now and talk about the fundamental components that work in harmony together to actually deliver the functionality of an AI agent. So at the center of this all is really the brain of the agent, the LLM. This is what you hear a lot about. This is where the reasoning actually takes place. The goals and objectives, instructions, you can think of this as the mission statement of the agent. This is what defines what its overarching goals are and guardrails and instructions. Next is tools. These, as I mentioned, are access to immediate real-time data or to interface with other applications, to interface with existing legacy applications. That's really why we're here today, and we're going to spend more time on tools in just a bit. Next is context. This is both short-term and long-term. In a conversational interface, which is fundamentally different from the user experience that we're all used to, you need to have context. What transpired before? Not just in that conversation, but perhaps 10 conversations back when you discovered insights into this particular user. This is where it really changes, and this is where agentic becomes so exciting. It's the ability of agents to take actions on their environments, observe the response and the results, make adjustments, develop new hypotheses, and then create and deploy new actions thereafter, and have an actual loop in this. If you've done any kind of playing around with agentic systems, the one that I actually love to use is like QCLI, for example. You can actually see this in actions where it actually develops hypothesis, might even deploy and create an on-the-fly application that executes against data, figure out that wasn't quite right, make an adjustment, and it keeps going until it gets right. This is what makes agentic AI the future for many of our organizations to work autonomously, to make decisions in a non-deterministic way. Now, I need to have a bit of a reality check here, because over the past year, we've worked with a lot of customers who have attempted implementation of not just agentic AI, but just AI in general. And the stat here is one that I've seen proven out in the field, and that 40% of agentic AI projects will be canceled at the end of 2017. The reality is that this is actually hard stuff. It's hard because the fundamental infrastructure and architecture is vastly different than what we are used to. And a lot of it just really hasn't existed yet to date. These are new standards, these are new capabilities, and it's been incredibly difficult to produce. And so we call this the prototype to production chasm. And so you start off with this idea of a proof of concept. And I'll be honest, like 90% of the time, it's some kind of chatbot, right? I urge you all to think beyond the chatbot. There's a lot of great implementations for agentic AI. But you have this idea, and it's just so much excitement and potential, and you get out there and you're starting to develop your agent, and then you try to deploy to production, and you realize that there's huge performance issues with your implementation. There's problems with scalability because it behaves differently from regular applications. Security is a concern. All of a sudden now you're opening up new attack vectors that you were not even aware of. And governance, you're violating particular regulations or policies within your organization. And we really fail to get any meaningful business value. Again, because needing to build everything from scratch is incredibly challenging. And that's why at AWS, we really want to be the best place to build the world's most useful AI agents. We want to empower you to deploy these agents reliably and at scale. And we're going to do this with 4 fundamental pillars. The first is building the state-of-the-art science. And this is in our own first-party models, such as Nova, frameworks such as Nova Act, or partners, and giving you model choice from companies such as Anthropic. Next, we want to provide the best-in-class infrastructure for running these agents. And these aren't just repurposed hardware to run agents. These are purpose-built to run agents for you in the best, most cost-optimal way. We want to deliver the best specialized agents because not every agent needs to be built from scratch. There's a lot of agents that can be reused from organization to organization, and we want to make sure that we're providing those to you in the easiest way to implement as possible. And finally, we want to provide every experience to be as intuitive and easy to use as possible. In the world of AI, it should reduce the friction for adoption of new technology, not make it harder. One of the key service features that I saw that got me as excited as that day in 2014 when Lambda and ECS were announced was this past summer when I was sitting at the New York Summit and the keynote was being delivered, and Amazon Bedrock AgentCore was announced. And if you've been in application development for many years, such as myself, many decades in fact, you start to see certain patterns emerge. And so just like Lambda and ECS provided compute platforms for modern cloud-native architectures, you can see similarities and patterns in what Amazon Bedrock AgentCore is delivering. And it immediately became clear to me that this will be the future of application modernization. Bedrock AgentCore, however, exists in a much more full, complete AWS AI stack. And so I talked about those purpose-built agents up at the top, and these are things like AWS Transform, Connect, Amazon Q. Our first-party models such as Nova, our partner models. AgentCore kind of sits there in the middle with Amazon Bedrock, where we give you model of choice, allowing you to pick the right model for the specific application that you're designing it for. All the way down to the compute layer and ML science layer that we've had for many years if you want to go and actually build your own models. Deploy on self-inference, on Trainium, or Inferentia under our custom silicon, for example. So AgentCore exists as part of this broader AWS AI stack. We want to give you choice, and we want to give you the primitives so that you can build in the way that best fits your organization and your business needs. Go fully managed with something like AgentCore, or go and control inference yourself and deploy on EKS. So let's walk through AgentCore just a bit, because we're going to spend a demo going over some of the detail. First up is the AgentCore runtime, and this provides the secure serverless environment for complete session isolation, supporting multimodal workloads and long-running agents. Next up is AgentCore Gateway. And this will be the service that we're going to demo here in just a bit. But this is going to provide a connection from the agent into the tools that are made available through existing legacy applications. Next is AgentCore Browser that provides you that browser runtime instance so that you can perform those browser-based events at scale. And then AgentCore Code Interpreter, where you can deploy codes in an isolated, protected environment that your agents run. This is all supported from a security perspective with AgentCore Identity, and AgentCore Memory helps you to manage that context that I spoke of earlier, both the short term as well as the long term. And AgentCore Observability gives you insights, logging, performance metrics across your entire AI agent framework. Let's now dive deep into AgentCore Gateway, which is the tool that will bridge agents to your legacy applications. So when we are working with customers that are starting to deploy agents, it first sees a lot of value just in working with the general knowledge of the LLM and doing things like text summarization or categorization, and there is value there. But what one quickly realizes is that agents, to be effective, need access to existing enterprise APIs, existing databases, existing knowledge bases. And agents are developed with different agent runtimes, different frameworks. And we were doing this internally in Amazon, and we were developing tens of thousands of agents internally. And it took months to set up each and every individual agent to interface with all of our other tools and resources. We needed to do something different to connect all of these. AgentCore Gateway is the answer for that. It simplifies the tool development and integration. So it gives you the ability to transform your existing APIs or Lambda functions into accessible tools that are based on the MCP standard. We take security as the highest priority here at AWS, and that is why AgentCore Gateway provides not just security and authorization for inbound transactions for access to the actual gateway, but outbound to your existing API agents as well, supporting your existing authentication and authorization frameworks. Finally, is a problem that is a fairly new problem as we actually roll out and deploy agents and tools, is the amount of tools that you want to give your agents access to begins to grow exponentially. And this causes extreme latency and unpredictable results in that non-deterministic environment. And so AgentCore Gateway integrates semantic search across your tools supported through the SDK. And so we'll go into an example of exactly how that works as well. So here's what the overlying architecture looks like in its most simplistic way. So you have agents that are running, and they're implementing the MCP protocol. They are the MCP client. AgentCore Gateway presents an MCP endpoint that your agent points to. Again, this is all based on the MCP standard. AgentCore Gateway then is configured to interface with all of your API tools and resources. And those APIs and tools can be REST endpoints, which is a very common architectural pattern for deploying APIs for years, or they can be AWS Lambda functions. So we have a lot of customers that have invested heavily in serverless architectures and deployed function as a service with AWS Lambda. All that investment can be reused and made accessible to AI agents. Let's take a look at how it works in terms of setting up this new AgentCore Gateway. So exposing MCP tools for existing REST service. So we have a REST service that's out there, it's existing, it's running based on the Open API standard. We have an existing identity provider, and that could be Okta, Intra, or Amazon Cognito. We'll go into the console, and we'll actually set up the gateway. We'll give it a name, a description, and we'll set up the inbound configuration using the existing identity provider of the application. We'll then set up a specific target to that REST API. Again, using the existing identity provider and the existing authentication and authorization mechanisms of that API. So we're not creating any end run around security. We're integrating and making security in a built-in environment. And then finally, we'll actually use this from the agent where we can list, invoke, or search with the search functionality that's provided by Amazon AgentCore Gateway. Let's go deep into the security. When the client invokes a request to go to the MCP endpoint for AgentCore Gateway, it's going to need to generate an OAuth token that it's going to send along. AgentCore Gateway is going to then consult the identity provider and determine if it has access inbound to that AgentCore Gateway. It will then check and see which resources it has access to on the outbound side, accessing those existing API and tools as Lambda functions or REST API endpoints. It then integrates with the existing authentication and authorization using either API keys, IAM, or OAuth tokens to access those existing API endpoints. All of this is supported from an observability standpoint using CloudTrail, AgentCore Observability, and of course, integration with AgentCore Identity. Let's take a look at the semantic search. And I mentioned that tools we found can explode exponentially. And so it's not uncommon to see customers that begin a path developing these agentic systems and providing access to tools, having tens, hundreds, if not thousands of different tools. And the way an LLM looks at these tools to determine which ones to use can increase with each of those tools that you provide. And so this is a big problem with conversational AI. Users have an expectation that responses and answers are given quickly. We had a little bit of a time period there where the newness of it was so amazing that if it took a few seconds and spun around, we were okay thinking, right, for 42 seconds. That's not going to last longer. People are going to want to have that immediate response. It won't be that much longer where it's going to really parallel what we've seen in web environments where users lose interest within, what is it, like 500 milliseconds or something ridiculous? Semantic search helps that. And so what it does is it actually takes a look at the context of the request and the context that the LM is operating in and allows you to use that to execute a semantic search on the tools that are available within the gateway. And so instead of getting hundreds of tools, you get a small subsection of tools that are actually applicable in the context that you're working within. This improves the accuracy, speed, and the cost, lets the agent focus on tools that are only relevant for the given task. All of the indexing and the search and the tokenization of all of the details of each and every tool is handled for you automatically by AgentCore Gateway. And all of the search infrastructure is provided serverlessly. So no additional servers or infrastructure to manage to provide that semantic search for your tools. So this was great for us, right? We had the ability now to use AgentCore Gateway. It provided the framework, the infrastructure, purpose-built that we can deploy all of our agents. We still struggled, though. We struggled from the developer experience perspective. We still were constantly repeating the same undifferentiated heavy lifting within code to get our agents working across our organization. We started to build some tools to abstract that complexity, to remove that friction for our developers that were building these agents, because we needed to move quickly. Last year, we released all of this to open source as Strands Agents SDK. This creates a framework that makes it incredibly easy to build agents. What used to take weeks or months can now be done in a few lines of code in minutes. This is open source, this is open use, and so we wanted to make sure that we're supporting all of the different AI agent runtimes, giving you choice of which models, as well as integration tightly with AgentCore and Amazon Bedrock. So this provided us with a lot of freedom to abstract away the complexity of agent communications to the developer to build these agents quickly. But as we were retrofitting these applications and making them use in agents, we still wanted to really leverage AI for the actual coding aspect of it. And so we launched Q Developer, followed by Q CLI. But last year, we released Kiro. Kiro is the AI IDE for bringing prototype to production. Introduced in Kiro was a concept of spec-based development. So you start with the specifications. The specifications can be generated in a conversational format. The agent helps to develop those, ask questions about those, and builds them into something that's human readable so that you can review and validate that the specifications match what you want to produce in your application. It'll then go through a design phase and then ultimately developing tasks to actually automate and execute. Kiro is now general availability. If you haven't already used it, I strongly urge you to download and give it a try. I'm introducing it here. We're going to use it in the demo, but we have a lot of great sessions that do a deep dive into all the features and functionality of Kiro. So strongly encourage you to go and check those out. Okay, so that concludes kind of the presentation portion. Gonna launch right into the demo now. Want to kind of display how you would integrate agents into legacy applications. So when I started thinking about the demo, I wanted to take something that was fairly well known and something that is ready to go and open source and available for you to actually download as well. So if you've been in application development and you have developed REST API endpoints, you're probably very familiar with OpenAPI, formerly known as Swagger. So OpenAPI developed an application that they use for demonstrating REST APIs and kind of showing you how they all work in a pristine way. And that is the Swagger Pet Store. So in this demo, I actually downloaded the Swagger Pet Store container and just deployed it to ECS on Fargate. I made no changes to this application. Just downloaded it from the GitHub repo, launched it up into the container, and it's up and running. And so it was responding to API calls, passes all the tests and everything, but absolutely no code changes whatsoever. So Swagger Pet Store is, oh, that's weird. So this is the got some AV problems going on here? Is it just that slide? Let me go to the next one. Okay. Apologies, not sure what's going on there. Well, imagine that this is showing an OpenAPI specification. If you're not familiar with OpenAPI, we're basically defining each of the endpoints. We give it a description, what the operation is, what the parameters in. And one thing I want to really emphasize here is AgentCore Gateway, the way that it operates with the OpenAPI spec and the way that it makes itself available to agents, it's highly dependent on your specification being very well documented, because it's going to use that specification to define the functionality and tasks of the actual agent. Okay. That's weird. All right, let's see if I can get this to work from over here, and we'll start the demo. There we go. All right, so first up is we are going to actually take a look at the settings for Kiro. The agent settings have this concept of steering files. So the steering files are what defines how Kiro operates. So I'm actually just going to go ahead and set this up with the Strands Agent SDK README as the steering file. So I'm going to go ahead and make a directory for Kiro in the steering, and we'll go into .kiro steering. That's where the steering files for Kiro exist. And now I'm going to go to the Strands Agent SDK website here, and we'll just click on the GitHub repo. GitHub repo has a README file for Strands SDK. This is where it defines what the quick start is, installation, and example implementation. Let's grab the raw URL here, And we're going to drop this into the Kiro steering directory. OK, so now we have a steering file for Kiro that's going to explain Strand's SDK. This is right from the repo. I didn't change anything. Let's go ahead and open that up and take a look. Under the Kiro directory, there we go. And README file is all there. Let me clean this up a little bit. OK, README file is all there. It's in kind of an HTML format. You can see it now in the Kiro settings. There's the agent steering. And we have this refine button. And the refine button is what is going to actually re-output the README file in a format that the AI agent actually understands. So you can see it's analyzing the README file. It's now converting it into a steering document that's a better guide for the AI assistant. You can see all of it changed. It dropped all the HTML stuff, put it into a markdown file, a README, and it kind of gives a description of exactly all the changes that were done. So structured around core concepts, made it easier to read. You can see the differences there from what I had, and all I needed to do was click on that refine button. Now if I open it up, I can go into kind of a preview so we can actually see that in a little prettier way. But this is in a format that the AI agent now can fully understand. This is a Kiro steering file, and so this is going to help in all of the subsequent interaction that I have with Kiro. OK, so clean that up a little bit. And cool. So now let's go ahead and start with kind of this vibe or spec. I talked a lot about spec, but for this purpose, we're going to go ahead and do vibe. And I'm just going to say, hey, let's create a minimal AI agent in Python that is terminal-based. And I'm going to specify that we're going to want to use Strand's agent SDK, period. That's it. And so you can see that we're including the steering file. That's the README document that I downloaded and I refined so that the agent within Kiro can understand it. So it's referencing that. It's creating the requirements for the application. It's creating the actual Python file. It's creating a README for this application. So this is already so much better than the developers I work with, where documentation actually exists while the code is actually being written. Once it's done, it actually gives a full definition of everything that has been created, project structure, features, and all of that. So let's go ahead and take a look at the actual agent that was developed in the actual code. So that's all in agent.py. So what you can see here is in just a single prompt and following the steering file, it's created an AI agent. And this is a fully functioning agent. But look at the code that got created. It's incredibly minimal. So a bunch of comments. You have 2 lines of kind of import statements there. And by line 23, it looks like the agent is already well-defined. So a few lines of code. And Strand's SDK abstracts a lot of the complexity of doing the streaming, doing the IAM authentication, connecting up to the Bedrock SDK. All I had to do is say, hey, I want a Bedrock model, and I specified Nova Pro here. Actually, Kiro picked that. I'll kind of go with it for now. OK. So looking down beyond that, the rest of the code is really just kind of doing terminal management, handling the inputs and outputs in the prompt. Because remember, I said I just wanted this to be terminal-based. Now, you could do something like Open Web UI if you want, but for this purpose, I'm just going to go ahead and do this in the console. Opening up the README, it not only says what the application does, but it says how to actually set it up. Requirements are all the libraries that need to be installed, and it's Python compliant. OK, so let's go ahead and give this thing a try and actually run this agent. So I could follow those instructions that it gave me, but I'm actually going to use Kiro here. And I'm going to say, hey, run this agent. And so this isn't a new session, so Kiro's looking at the README of the application. How do I run this thing? What's the code? Let me validate it. Let me see the requirements here. And already it ran into its first problem, right? The libraries aren't actually installed already. So it saw the error, it interpreted the error, and said, hey, I need to actually install these libraries. So it goes in and it's going to install the libraries, and then it finds another error, and that is that, hey, everything's running here in a virtual environment. So you've got to set up a virtual environment first. And then it wants to execute that in the virtual environment, but it's saying, hey, I haven't ran this first, so you have to actually give me permission. So I'm going to give it permission, and we're going to execute the library installation, or Kiro is going to execute the library installation for our Python application. So there we go. All the requirements are actually installed. Now it's looking at everything, saying, hey, looks like I'm ready to go. I want to run this thing. But again, it says, hey, this is new code to run. Validate, I do. Here we see initializing strands agent. And it looks like everything is running, but Kiro's still waiting because I'm kind of in a terminal wait here, so let me exit. Now Kiro sees everything is running successfully. There's no errors. Congratulations. It looks like everything's good to go. So let me actually run the agent now. And remember that this is a pet store application, right? So what I've done so far, though, is I've just created a new agent using Strands SDK. I'm not connecting to any legacy pet store at all. I am connecting to Bedrock, though. So this is an AI agent that is using Bedrock, the Nova Pro model, that I can interact with. So I'm just going to simulate kind of what I would in a pet store. And let's just go ahead and say, hey, you know what? I want to, let me clean this up here. There we go. So I'll say, hey, I want to adopt a pet here. But I want the pet to make sure that they're good with kids. So that's going to actually send the request to the LLM with Bedrock, and it's going to answer back using the LLM's general knowledge. So I just said, hey, I want to adopt a pet, and the LLM is more than happy to comply. It says, hey, sounds good to me. If you want to adopt pets, dogs are great. Who doesn't love a golden retriever, right? Labradors, beagles. These are all answers from the general knowledge of what a good pet to adopt for kids actually is. And then down at the bottom, you can even see that it has some tips. Again, this is the agent actually taking freedom here to add additional information. Okay. Let's now connect the legacy application. So I'm going to go to the AWS console. I'm going to search here for AgentCore Gateway, or excuse me, AgentCore. And I'm going to go into, under Build and Deploy, we have Gateways. And under Gateways, I'm just going to go to Create a brand new gateway. And here I'll give it a name, so we'll call this Pet Store Gateway. I've got some additional description if I want, instructions. Here's where I enable the semantic search that I talked about. But for this demo and purpose, we're going to go ahead and leave that off for now. The inbound auth configuration, I can connect to existing Cognito, but for now, I'm just going to use the create a new one. Same with the service role. You can connect an existing service role, but I'm going to allow the console to create this for me. And then here's where I define the actual target. So we have gateway and target. So I'm going to define the pet store API here. And we're going to define this as the REST API. That's the one you had to imagine earlier, right? So we can upload the REST API, or we can actually paste it in here. I'm going to paste it in. And this is just the JSON Open API document that I showed you earlier. So I just copy and pasted that right into the console. Earlier, I created an API key to access the API, so I'm just selecting it here and clicking Create Gateway. And that's it. All the definition was in the Open API, the endpoint, all the REST APIs were all defined within that Open API spec. So the gateway was created successfully. You can see some ARNs and some endpoints there. It says that the status of that gateway is ready to go, so we can actually start using it. And the target is there and defined, and that's listed as ready as well. So that target is the actual REST API that I defined in that open API spec there. The console also shows some invocation code. So here it actually supports Strand's MCP client example code that you can go through and scroll and take a look at, and you can actually copy it for implementation if you want to. I'm not going to actually copy all of that code and try to modify it and implement it. What I'm going to do instead is I'm going to go back to Kiro here. So I'm going to copy the MCP URL endpoint here straight out of the console. And go back to Kiro, and I'm just going to tell Kiro that I now want to update this existing agent with the new MCP endpoint that I copied from that console there. So update the agent to use the MCP tools paste in the endpoint. And that's it. So it's going to pull in the steering document. The steering document is going to instruct, hey, here's how you actually implement MCP with Agent SDK. And so it's updating all of that code now. And so it's working through the agent Python file, making those updates. There we go. We can see the two different files that it was, or excuse me, two edits that it made to agent.py. It added additional libraries and requirements to work with the MCP, and it even updated the documentation. There we go. So all the code is done. It actually even goes through and does a compilation to make sure that there's no errors, validates it, and then it's going to report all of the changes that were made. There we go. Let's take a look at all the changes. You can see these new code additions, increased import libraries that have been added. This is the access token, the OAuth token that now needs to get created to actually interface with the MCP, and then the actual code to create the agent using the MCP URL. So again, these are all code changes that I didn't need to make, but Kiro was able to make just based on the instructions that I gave to it here. Okay, so let's go ahead and set up the final piece, which is the actual OAuth token generation, the authentication piece. So here's the token URL that I'm going to need, but I'm actually going to need the client ID and secret, and I grabbed that over from the Cognito console. So remember I said I wanted to create a new Cognito user pool, so that got created over here. And then I grabbed the client ID. For that, you go over on the left-hand side under, I think it's applications, and then, applications, app clients. So there's the app client that was created by the gateway console definition, and my client ID and my client secret are available there. So that's what I need to actually update. Remember, Kiro told me I needed to update these to the environment variables. And we can see that in the code that got generated. I have these 3 environment variables that want to get set. So I'll start with the MCP client ID. And we'll grab that from the console. We'll just copy that from Cognito. And we're going to paste that in here. Next, the MCP client secret, and we get that from Cognito as well. And then finally is the MCP token URL. And this is the one that we saw earlier that we can get from the actual code sample in AgentCore Gateway. So we'll go back there. Paste that final one in. All right, so now we have all of the credentials that we need for the environment variables. And so now we're ready to run this new agent that now has access to our entire pet store. All right, let's clean this up a little bit, make this a little bigger. Okay, now we're going to run the agent. You can see here that we see setting up our MCP connection, and it says connected to MCP endpoint with 18 tools available. So this is all done with the gateway. And I'm going to actually pose the exact same question. I would like to adopt a pet that is good with kids. And here's where you'll notice something different. It's actually executing tools. It's using the pet store find pet by status API endpoint. It's finding a bunch of pets that are currently available for adoption. It then goes in and says it wants something that's friendly with kids. It makes a determination of what tags might be. Then it does find pets by tags. And it goes through and it finds all of these pets that are available in the running pet store, the legacy application that I did not need to change, and can find all of these different pets by status and by tags based on friendly and other different tags that matches the context of I want to adopt a pet that's good with kids. And I find specific pets here. So I have a dog named Buddy. I have a dog named Happy Test Pet. Looks like another dog named Max. And then it even presents some additional options there. So let's look at how this works in context. So I'm going to say, give me more details about Buddy. Buddy was defined in a return value before, but it already knows what that specific pet ID was for Buddy. And so it goes back to the tool to get details about Buddy and gives different photo URLs, specific information about Buddy, how long it's been available for adoption, and then integrates that with the agent general knowledge to give more information about learning about the adoption process, what to expect from a dog, and all of these things. So what we're demonstrating and what you're seeing here is an agent that is using an existing application that has not been changed in a non-deterministic way. So imagine this pet store that has a UI that you have to define. You have to think about how your user is going to interact with your system. So you might have a list of pets that are available, but you might not have encountered this idea that people are going to want to look for pets with certain behavioral traits. But because you have the API that can function this, the agent designs this access in a way of using the tools to satisfy the requirement, combines that with general knowledge, and gives very meaningful results and allows you to bridge legacy to AI agents and use them in meaningful ways. So let's take this just a step further here. And let's say I want any pets that would not be good for kids. So I've been talking about good with kids and friendly. So let's throw the agent a curveball and let's take a look at pets that would not be good for kids. And so what it's doing is remembering that it found these traits by using these find pets by tags. And so it's iterating on different behavioral traits and personalities and executing that using tools with the find pets by tag endpoint, with the existing API using the existing application that's running up in ECS. So it found a few pets, it looks like, and now it remembered that I wanted to get details before, so it's actually executing those get pets by ID. And it found a few. So here's, it looks like a dog, and here's an exotic animal, and it's even explaining why those specific pets would not make for would not make good pets that were friendly with kids. So this one that's shy, for example, says shy temperament, may be overwhelmed by children's energy. That's combining the general knowledge with the details of this specific pet here, right? Okay, finally, I'm going to say, hey, are there any cats? Because you said a better option was cats here. So now I'm going to actually say, let me see if there's any pets by a specific breed here, right? And it goes through and executes find pet by status again, and now it has a different objective. It's going to actually go through and find specific cats, and it looks like it found one. It found a cat named Max. It remembers that I was looking for a pet that's good with kids, and so it's going to integrate there and, using the general knowledge, explain why cats are good pets with kids. So that's the end of the demo, but I wanted to just take an existing off-the-shelf application and show how you can integrate it with the agent. What I strongly urge everybody to do is continue this journey and dive deep into AgentCore. You can use the URLs here. We have a lot of sessions that are based around AgentCore, AgentCore Gateway, as well as strands. But more than anything, not just deep diving, I really encourage you to start actual using. Don't wait till tomorrow or wait until next week or even next month. As soon as you get back, think about where agents would make a difference in your organization. Develop that use case. Develop the business value, prove it out, and then repeat. I wanted to thank everybody. I apologize for a little bit of the AV issues there, but hopefully you're able to imagine the open API. I'll be around for a few minutes afterwards if you had any questions at all. Please enjoy the rest of reInvent. Thank you so much.